Welcome back to this lecture on web service composition. The topic of this video is orchestration, one of the two paradigms we will see in the lecture. So, first of all, why are we talking about orchestration? So, the term comes from an analogy with a common orchestra, where we have musicians and then we have a director. The musicians, of course, they know how to play, but it is the director who gives them the right rhythm, who tells each individual musician when to start, how to put the emphasis, how strong or soft to play, and so on. So in the end, it is the director who orchestrates the orchestra. So if we go to web services, let's try to understand the analogy. So we have again a set of web services that we want to integrate. And as said before with the musicians, here also the web services, they know how to do their own business. I mean, they know how to execute their internal business logic. Then we have an orchestration engine, which is essentially the director who now knows how to invoke the different services so as to implement our composite service. How does the orchestration engine actually know what to do? It parses or it reads a so-called composition schema. And the composition schema is what the service composer, the developer, actually develops. This is then handed over to the orchestration engine, and the orchestration engine executes the composition. So here the analogy between the director and the orchestration engine. How does a composition schema look like, or how can you imagine the composition schema? It's essentially what is called a workflow model, where the model is a graph, it's a schema of activities that are specific to the problem domain of composition. For example, we have the composition activities to invoke services, we have activities to receive messages from external services, we have activities to rule the data flow, to rule control flows, and so on. And the result is a simple graph model. In this case here, for example, we have a composite service that invokes a set of other web services. We can imagine that each of the boxes here communicates with one of the external web services. For example, the first activity communicates with web service 1, the second activity communicates with web service 4, and so on. And it is this graph model here that specifies the logic of the composite service. As soon as we have integrated all of the services, our composite service is ready for execution, and it can be published as again as a composite web service on the internet. So let's try to give a more precise definition of orchestration. So an orchestration is a centralized integration logic that describes how web services must interact with each other at the message level so as to achieve a given goal. The goal in our introduction example was the development of a book order management process. And the orchestration tells exactly how to invoke each individual service involved in this process so as to achieve this goal. So an orchestration, it essentially, as we have seen in the picture before, it instructs the orchestrator how to invoke the services, how to mediate between them, how to order service invocations, and how to deal with exceptional situations, and so on. So it is essentially the recipe of the composition. The very important aspect in this whole context here is that the web services themselves are actually completely unaware of what's going on, meaning they don't know that they are part of the orchestration. They only know that they are interacting with a client. They don't know that the client they are interacting with is actually our composition that also interacts with other web services. They don't know, and we can also say they essentially don't care, because what they care about is just the client-server invocation or conversation between them and us. It is up to the composition logic to to orchestrate different conversations with different web services so as to implement a new value-adding logic. How do we implement such a value-adding logic? Let's have a look at a typical service composition environment. We are, I would say, the schema designer here in the left-hand side of the architecture, and we have our idea of a service composition. So the first key ingredient in order to develop a web service composition is the so-called composition model. So what is the composition model? The composition model determines which composition features are supported by the composition environment. So it essentially tells how services can be integrated. In the context of web services, for example, we specify in the composition model whether our composite application can invoke services only sequentially, or whether we also allow web services to be invoked in parallel. It is here where we specify whether we want to have decision points or not, which kind of operations of the web services to support, only synchronous operations or also asynchronous operations, whether we want to have correlation, yes or no. This is done at a very conceptual high level, and this is called the composition model. But then in much more practical terms, as the schema designers, we need to have a tool, a graphical modeling instrument that allows us to draw this workflow, this composition schema we saw before. And for this we have a graphical user environment that allows us to make a drag and drop development of this composition logic and to put together composition constructs at a visual, intuitive, and relatively fast, let's say, level. This graphical user environment is, as the name already says, it's oriented toward human users. This is not yet oriented to the orchestration engine we saw before. This is oriented toward the human users, and it is an abstraction of what is going on in the orchestration engine. So in order to talk to the orchestration engine and to really instruct the orchestration engine how to compose the services we want to glue together, we also need a composition language. So the composition language, you can imagine it as a textual XML or some similar representation of the composition schema before, but this time oriented toward the runtime environment for the execution of the composition. This runtime environment, in essence, it's the orchestration engine, the director of our orchestra. Usually we don't directly write in this composition language, and we as developers, we use some abstractions on top and tools on top, but we could also directly write this kind of language. So once we have the composition schema in our composition language, we can hand it over to the runtime environment, which is essentially able to interpret the composition schema, to parse it, and to enact all the activities specified in this composition schema, thereby enacting the composite service. Of course, as a final component in the whole architecture, it's partly outside of the, let's say, of the web service composition environment, but we need some just generic SOA, so service-oriented architecture, middleware, like as we said before, there was discovery and security and transactionality and so on, and these are typically provided outside of the composition environment and provided in the form of some library or some middleware. The composition environment is built on top. Okay, so let's have a look at an example of a concrete web service composition language. Specifically, we want to have a look now into the business process execution language. It's called BPEL for short, and commonly known as BPEL. So BPEL is, I would say, the most popular web service composition language that we have today. It's based on XML, and it comes with a set of constructs that are specifically tailored to the needs of composition. So it is not a generic programming language, It is very specific to composition only. It can be used to model essentially two different kinds of processes. First, we have executable processes, which are processes or workflows. We use process and workflow as synonyms. Executable processes, we can hand them over to the orchestration engine and they are ready for execution. But then we can also describe non-executable, so-called abstract processes, which are templates and which are more higher level process definition that still need to be instantiated by the developer in order to turn them into executable processes so that the orchestration engine can then really execute them. The official reference of the BPEL language is an OASIS standard that you can find online at the address that you can find here on the slide. Okay, let's have a look at the overall concept of a BPEL composition. Let me take again the pen. So we have one big block. This represents our composite service. Inside we have activities. The activities want to communicate with web services at the outside. And in order to communicate with these web services on the outside, we have a set of interfaces toward the outside, which are the so-called port types, through which the internal composition supports communication with web services. So these port types serve a bi-directional purpose. Let's say on the one side we can send messages from the inside toward the outside, and at the other hand services from the outside can send messages or communications from the outside to the inside of our composition. So this was a very simple, let's say, summary of the concept of BPEL. We can have more details if we look at the metamodel of the BPEL language, which is essentially a model that expresses all the composition constructs part of the language. First of all, we have a process. The composition is called the process, and the process integrates a set of partners, and the partners are accessed through the partner links. Then we have a set of activities, and specifically there are a set of activities that we can group. We have basic activities, and these are the activities that we simply need to interact with web services. So we have invoke, receive, and reply messages or activities. Then we have structured activities. These help you to specify the control flow of your composition. So there are flow activities, which are essentially parallel activities. Then we have while construct for loops, pick constructs for inputs that must come from the outside, and sequences, and so on. We have some additional auxiliary activities like waiting, compensating, empty or exiting a process, throwing exceptions, assigning data to variables. By the way, we also have variables here on top. So variables, we need them to store intermediate results coming from the web services and then to take decisions. So the decisions we made, the control flow decisions we make, they may look into the content of the variables, and based on the outcome or based on the content of the variables, take different routing decisions. Then next, BPEL comes with constructs for exception handlers, which are, let's say, event handlers first. Event handlers are constructs that allow to deal with messages or alarms generated inside our composite web service. And fault handlers are event handlers. They are a subtype of event handlers in a sense that allow to deal faults. For example, if an invocation fails, if we want to invoke a service and the service is not available, or there's a network problem or so on, we need to be able to catch this fault and then to react to this fault. And then finally, I would say we have the so-called correlation set, which we have explained already in the first video briefly. So the correlation set is needed to identify properties inside the messages exchanged between the different web services and to correlate messages based, for example, on a given conversation identifier or a product identifier or similar. Let's have a look at a trivial example. A loan approval process. So this process here, the process is in the middle, it is so trivial that it actually doesn't do anything. So what we do here is we have a client or a customer at the left hand side, and we have a financial institution approving or not approving, let's say, the loan request on the right hand side. We place our composition in the middle, and the only thing we do is we just forward the request from the customer, we forward it to the financial institution. What does this mean in practice? We obtain a loan request from the customer, and we do this by means of a receive activity. Then we store temporarily the request in a variable, so as to invoke afterwards the financial institution's web service by passing the request as an input to the message, to the web service. In response to this, we get a confirmation or a rejection back from the financial institution. Again, we store the result in a variable, and then we reply the outcome of the loan request to the customer by means of another message directed to the customer's machine. Let's see a concrete example of how to use BPEL in practice. We start the BPEL definition with a traditional header where we specify the name of the composition. In this case, it's loan approval process. And then we have a set of the namespace definitions, one for our own namespace, the default namespace, and then we import some other namespaces. For example, one from the WSTL file that we don't show in this presentation here, but the BPEL process exposes again a web service, and so we also have a WSTL file for this process already developed before. What is more interesting is how to define the partners. As we saw before in the picture, we have two partners. On the one side we have the customer, at the other side we have the financial institution, which we call approver. So the customer and the approver. And these are the two parties we want to integrate in this simple composition. Then we obtain an input from the customer and we forward this input to the loan approver, and this requires storing the data in an intermediate variable. So we define here two different variables. One we call request, and this is simply the variable where we store the incoming loan approval request from our customer. And then we have another variable which we call approval info. This variable we use to store the feedback that we get from the financial institution. After defining the partners involved in our composition and the variables we need to pass data from one service to the other, we can specify the actual composition logic. In this case, it's very trivial. As I said before, we essentially have just one sequence of actions. We receive the loan request from the user, we forward it to the financial institution, get back the loan approval feedback, meaning yes or no, and then we take this feedback and we send it back to our customer. So in practical terms, or let's say in XML terms in BPEL, this means we have a receive activity named receive1, where the customer provides us with the actual loan request that we store in the request variable. Once we have it in the request variable, we can go on and invoke the financial institution's web service. This is called invoke approver in our process, and the partner is the approver. We take as input of the invocation the content of the request variable we just got from the customer, and the output we obtained from the financial institution, we store it in the approval info variable. This is the variable that will hold the yes or no answer from the financial institution. Then finally, we can now invoke, or better reply to our customer with the yes or no answer. This means we have a reply activity in BPEL toward the customer, and we send the approval info or the content of the approval info variable. This closes our process, and this is essentially the composition logic in BPEL. Of course, there are many other composition constructs. It doesn't make sense in this brief introduction here to go into all the details. The important thing is that you got the essence of the approach. As said before, as a human user or a human developer, you are not supposed to really develop these XML specifications on your own or by hand. There are graphical development tools there. For example, there's the Eclipse BPEL designer that provides some graphical abstractions or representations of the XML format of BPEL. And of course, graphical development is perhaps easier than developing XML yourself. That's all for this video, and in the next video we see how to develop a choreography.